So here is a linear programming problem. This is not one like you'll see on the computer, but it's a great problem for you to see what linear programming is about. So on this problem, we're going into business, and we are going to do two juice mixtures. We're going to call them Hawaiian and tropical. There are recipes for these mixtures. The products are made by combining two resources. We have pure cranberry juice and pure apple juice. We combine them in these proportions. 3 quarts of cranberry juice and 1 quart of apple juice make 1 gallon of Hawaiian. And 2 quarts of apple with 2 quarts of cranberry juice make 1 gallon of tropical. Well, we need to see what resources we have today. Today, we have 200 quarts of cranberry juice and 100 quarts of apple juice available. We saying we going into business here. We make a profit of 30 cents a gallon on Hawaiian and 40 cents a gallon on tropical. How many gallons of each product should be produced to get the highest profit without exceeding available supplies? So if we're going into business, that's what we're interested in, right? The money. We want to get the highest amount of profit. Well, on the other page I gave you, which we'll use for this other problem, here are some questions. If you like, where do I start? Here's some questions for you to answer to start figuring out this problem. What are the resources? What are the products? What are the recipes? I call it recipes just because a lot of the problems, like the juice problem, we might be making some food product. So what are the recipes? How many people are helped? Well, that's our profit actually on the juice problem. What do we want to find? So for this problem right here, I'll fill in some of those questions with the resources. On the juice problem, they are cranberry juice and apple juice. Cranberry juice, apple juice. After resources, I'm going to put a little question mark. That's what we have to work with. What are the products? On the juice problem, this is our 2 juice mixtures. 2 juice mixtures. On this juice problem, that is Hawaiian and tropical. I want to know what are the recipes for creating each of these. So if I look back at the problem, I'll figure that out. I'll read that. So the Hawaiian, to make 1 gallon of Hawaiian, well, let's see, here it is. 3 quarts of cranberry and 1 quart of apple make 1 gallon of Hawaiian. So Hawaiian takes 3 quarts of cranberry and 1 quart of apple. Tropical, that will take 2 quarts of each. Let's see, 2 quarts of apple and 2 quarts of cranberry. Just wanted to double check that. 2 quarts of cranberry and 2 quarts of apple. What is the profit from each? That's another question. Profit from each. And if I read the problem, they make 30 cents on Hawaiian and 40 cents on tropical. Hawaiian, 30 cents a gallon, and tropical, 40 cents a gallon. So you have to kind of pull all that from the problem. Take that information and fill in, I call it a linear programming chart. On my linear programming chart, these 4 boxes right here, that's the recipes. So as I look at this, Hawaiian takes 3 quarts of cranberry and 1 quart of apple, and tropical takes 2 quarts of cranberry and 2 quarts of apple. The resource limits, that's how much we have of each. What did it say in this problem? Today there are 200 quarts of cranberry and 100 quarts of apple juice. Cranberry, 200, apple, 100. I put it in the chart. I didn't say it, but my variables are X and Y. X is the number of gallons of Hawaiian, and Y is the number of gallons of tropical. In this column for Hawaiian, put an X next to each one of those numbers. And in the column for tropical, put a Y next to those 2 numbers. The last line on the table is what your book calls the objective function. Sometimes you'll hear me call it the profit function. Your book uses Z for that, but right here we're going to write Hawaiian, 30 cents a gallon. I'll write 0.30. And tropical, 40 cents a gallon. Put the X next to 30 cents. Put Y next to 40 cents. X and Y represent the number of gallons of each. You know, if X was 2, I would do 0.30 times 2. I got 60 cents profit. If X is 10, 0.30 times 10, I'd have $3 profit. So that's your setup. The constraints. This represents limitations on how much of the product we can make. For the resource constraints, take the line for cranberry and read it straight across. Put a plus sign between 3x and 2y. Put less than or equal to. I cannot use more than 200 quarts of cranberry because that's all I have. So my resource constraint, 3x plus 2y is less than or equal to 200. What is it for the apple juice? 1x plus 2y is less than or equal to 100. You do not need to write the 1 in front of the x. These 2 inequalities, these 2 are things you're going to graph. We'll graph these. We're going to have to find the intercepts, and we're going to have to find the intersection point. So I'll graph those. My objective function, your book uses a Z for that. Z equals 0.30x plus 0.40y. Let's work on these graphs. I'll write graph 3x plus 2y is less than or equal to 200. And I'll write the other one on the side. 1x plus 2y is less than or equal to 100. On each of them, I will have to graph the line first. Solid line or dashed line? Solid, because it has the equal to part. For this, I will first graph 3x plus 2y equals 200. Find the x-intercepts. For these problems, you have to have the x-intercepts in your graph.
What do you graph this equal to?
This equation or inequality represents the maximum amount of cranberry juice available. So I can make products that equal 200 quarts, whatever combination I pick. So we'll graph the equal to part for that. For the x-intercept, I'm going to put y equal to 0. So this will give me 3x plus 2 times 0 equals 200. 3x plus 0 equals 200. 3x equals 200. When you divide by 3, we'll get x equals 200 over 3. I'd probably leave it like that, but I do kind of want to know where that will be on the graph. So I'll put in 200 divided by 3, 66 point repeating 6. That actually in fractions would be 66 2/3. For the x-intercept, no, the y-intercept, we just found x. For the y-intercept, x equals 0. This will give us 3 times 0 plus 2y equals 200. So 2y equals 200. When you divide, you'll get y equals 100. For the cranberry line, let's see, let me go ahead and get my graph paper ready.